Find the EAR, or effective annual return, in each of the following cases. In the first case, we're told that the stated rate, or APR, is 8%, and we have quarterly compounding. We can calculate the EAR using the formula EAR equals 1 plus the APR divided by m to the m power minus 1. So in this case, we would have 1 plus the 8% APR divided by 4 for the number of quarterly compounding periods to the 4th power minus 1. And solving, we find the APR of 8% with quarterly compounding translates into an 8.24% EAR. We could also do this calculation using your financial calculator. Recall, we have quarterly compounding. This means we'll enter 4 for the number of periods. For our interest rate, we'll take our 8% and divide it by 4 and enter 2 for the interest rate. If we begin with a $1 present value or initial investment, putting in 0 for the payment, and solve for the future value, we find that the future value of our investment grows to 1.0824. This means our $1 initial investment grew to 1.0824, or we have earned 8.24 cents in interest, which translates to an EAR of 8.24%. Notice, in both cases, the EAR is simply equal to the future value of 1.0824 minus $1, which would represent the initial investment. In case 2, we're given a 16% APR and told that we have monthly compounding. To use our mathematical formula, we would have the EAR equals 1 plus 0.16 divided by 12 to the 12th power minus 1. Solving for this, we get an EAR of 17.23%. Using our financial calculator, we can make a similar calculation. We'll enter 12 for the number of periods since we have monthly compounding. For the interest rate, we'll take the 16% interest rate and divide it by 12. We'll begin with an initial investment of $1 today, put in 0 for the payment, and solve for the future value. Our $1 initial investment grows to 1.1723. We have earned 17.23 cents in interest on our initial investment, or an EAR of 17.23%. In case number 4, we're given a 15% interest rate and told that we have infinite or continuous compounding. The formula for continuous compounding is our exponential function, e to the 0.15 power minus 1. In solving this, we get an EAR of 16.18%. We can solve this also using the financial functions in our financial calculators. Again, continuous compounding means we have an infinite number of compounding periods, but fortunately, we can just pick a rather large number for n. Let's say pick 10,000, so enter n equals 10,000. For our interest rate, we'll have to take our interest rate of 15% and divide it by the same very large number, in this case $10,000 or 10,000. We'll enter 1 for our initial present value, 0 for the payment, and we'll solve for the future value. Our $1 initial investment grew to 1.1618. We have earned 16.18 cents in interest on our initial investment for an EAR of 16.18%.